Hello guys, welcome back to our final video of the object-oriented programming in Python. In this video, we will go beyond simple inheritance and simple concepts and try to design a modular system using composition. By the end, our chatbot will be broken into different components: memory, natural language processing engine, and response engine, which makes it easier to extend and it make it scalable. So far, we've used inheritance to create different personalities for our chatbot. That works well when the variation of things are basically in the same type. But sometimes you want to build object using smaller pieces and smaller components, like building blocks, rather than just extending a parent. That's composition. So if I want to give you an example in the real world, a sport car is the inheritance of the car as a parent. But if we are talking about the composition in the car concept, engine, tires, seats, they're all part of the components which you need to combine together to create a car. For our chatbot examples, inheritance works for the sarcastic and friendly chatbot, for the personalities that we define. Composition, however, works for features like memory, natural language processing part, or even the response part. Let's start breaking our chatbot into the pieces that we can use. From the previous examples from the chatbot, we have this class of the chatbot. The main class includes all the parts that we want to separate. Let's start with the memory. We have the remember and recall memory. In order to do this, we define the class memory. And in the init function, we use something like this. So the name part, of course, will be not part of the memory since it's only the component of the memory, but the memory part will be, of course, the variable that we want our memory to have. So in order to extend this class, we need to move also these two parts to our components memory. So now the remember and recall parts are part of the class of the memory. We can also delete this part from chatbot in order to make it totally separate. The next part that we want to define is NLP Engine. For that, we also define a class. For the first method, we define a static method. And the static method, as we had from the previous video, I can actually copy paste it from here, is the greeting part. Another static method that we want to add to this class is tokenizer. So tokenizer get the message, make it a lowercase, and split the message into the tokens. You don't need to know what tokenizer is or what it does. The only thing here for you, the important part, is it will get the message and make each word separate. That's the only thing that you need to know. The next class is the response class. Of course, we want our chatbot to respond to a user. So we call it like that response engine. It generates response. It gets message and also it gets the NLP engine. The NLP engine here, the type is, of course, our class that we define here. You can also add a type here. For this series, I didn't use types because we wanted to focus only on the object-oriented programming. But in case that you want to add a type, you can easily add it like that. Then at least you make sure that this input is related to NLP engine. This avoids any unwanted input to be added here, but this is basically optional. It makes your code much more readable and also easier for people to use your API or your code whenever they want to modify it or if they want to use it as an API. Anyway, let's define our generate response. So the generate response here has a condition. If the NLP engine recognizes that the message is greeting, it will respond like the greeting. We have also here defined a response. Response is hi there, nice to meet you. And in case there is no greeting, we just return what user said. We say you said the message that user inputs. Now we have three components which we separated from each other, and by combining those we want to create our chatbot. Let's see how we can do that. So the chatbot now consists of three elements, these three components that we want to add to the chatbot. So the first one is the memory. The memory, we can give it easily as an input. The second one is NLP engine. I will add the type of each input in order to make it easier for you to understand where those inputs are coming from. I would add a type for each input in order to make the code a bit more readable, especially in the case that we define our own components, which we will give as an input to the chatbot. Okay, like the name, we want each of these chatbot objects have their own. Like the name, we want each of the chatbot objects that we create from the chatbot parent has their own memory NLP Engine response. We can add it like the name that we add on the above. We can also rename this response to response engine to have the same shape as the class's name. Okay, this is the initialization part. We want to now change the chatbot, how we chat with this chatbot. Let's define that method as well. What we want to do at first is to remember the message that our chatbot get as an input from the user. So we easily use the memory object, and from the memory, the remember part is the one which we append to our internal memory or private memory. Now we give it as a memory. The next part, of course, is that to give a response to the user. Here, the response we can easily do like the self response engine, and we generate a response. From the generate response function, we can see also from here, we have a message, we add the message, and the NLP engine. The NLP engine, we initialize it inside the chatbot, so we use that engine. And this is as easy as it looks like. So we can easily change your response engine or whatever the components that you want to change, and easily like a building block, build your own chatbot. Just as additional example, here we remove this part. These are the old codes that we had from previous example. We clean everything up and we call the recall memory, or we just call it recall, maybe that's easier. You can pause the video, just think about it, what can we do here? We want to use the memory class, of course, because the recall is from the recall memory. What we do, we said that let's do the memory, but as you may know, you cannot really use this memory here. You need to basically call the functions that we define here, recall memory. And based on the dunder method, for example, we want to also check what kind of objects we are dealing with. We use the str1 in case that we use the print function, for example, to print our object. Then we return self name. To use this in our example, let's start to create all these components first. Then based on those components, we create our chatbot. The first one, of course, is the memory. In the memory, we can easily define it like this because everything has been defined in the initialization function without any input. With the NLP engine, it's NLP engine like this. And with the response engine, of course, not the class. We can define the response engine like this. Okay, the bot is defined like this. Chatbot, we need to put the name. The name is, of course, we use the famous Aiden. The memory is the memory that we defined here above. The NLP engine is the NLP engine that we defined above, and also the response engine the same. And that's it. You create the object based on the components. Let's check with the print function how this object is behaving. The first one, we chat with the chatbot like hello. The second one, we want to give different message because we define an if condition for it, if you remember. So for example, how are you? And at the end, we want to check if everything has been saved inside the bots that we have, inside the bots memory, basically. Let's also check how the class, let's check. Okay, here the print function, the first one, say that hi there, nice to meet you, because we send hello. The second one, since it didn't recognize it in our response components, here it needs to respond it back that you said, how are you? The memory in the recall saves all the message that I as a user sent to the chatbot, and the final print function basically shows that the chatbot is Aiden, as we define it in the dunder method inside the chatbot class. And notice how neat and nice the design is. You can swap every component that you want in this design without thinking about other components. You want a smarter NLP engine, you can just easily define a new NLP engine, which is smarter, and for example, using ChatGPT. The response part and the memory part will remain the same. Or you want a different personality like we had defined before in the previous videos. You can easily swap the response engine with different personalities that you want. And you don't need to write the whole chatbot to achieve that. So if you want to briefly connect this design to the best practice design in software engineering, we can define these principles which we already implemented here. The first one is single responsibility principle, or SRP, which means that each class should do only one thing. The second one is dry, or don't repeat yourself. For example, logic like greeting detection. It lives only in one place and not spread everywhere. And the last but not least, solid principle. This chatbot design is extensible and it opens to the new features without changing the existing class. This is how professional object-oriented programming design makes projects scalable. Let's see our chatbot again in action. For example, we want to add a new personality without touching the main class. Let's call it like friendly response engine. So here, in order to make it easier to understand, I copy-paste this engine and I call it friendly response engine. It generates the response, the same structure as generator response. The NLP engine is detecting the greeting, but we change the response to a friendly response. That, for example, hey friend, is very friendly, like that. Let's not make it so fancy. So happy to meet you. That's awesome. Tell me more about this. And awesome has a dictation problem, typo, and that should be okay. Now in the main chatbot, we don't need to change anything here. What we need to do, we need to define here the new friendly response engine. What we need to do here is just replace this part with the response engine, the default response engine that we had before. And when we replace it and run the code, you can see the response engine has been replaced. Now we have friendly chatbot, but the memory part, the NLP part, they're the same. And how we can do it without touching other part of the class, that makes the design scalable. Congratulations, you've just built the modular and extensible chatbot using advanced object-oriented programming in Python. That's it about this series. You have already learned a lot of things. You learned what are the classes, the attributes and methods, how encapsulation, inheritance, and polymorphism works, how can you use class methods, static methods, dunder methods, and finally the composition and principle of clean design. With these learnings, you need to, of course, train and define your own projects and use these techniques in your own projects. So by that, it's your turn. Extend this chatbot, add the new components, even connect it to the API like ChatGPT to make it very smart. The sky is your limit, of course. Good luck, good morning, and good afternoon, and good evening. Bye.